On our third formative assessment, we were asked to solve a polynomial equation, specifically to find all the real solutions to this equation and to justify each step. So clearly we have a cubic equation here with a single variable, so it is a polynomial. And the first thing I think about when I solve polynomials is I try to get all the terms on one side and to write it in standard form. So what I'm going to do is I'm going to subtract 10x and 15 from both sides of this equation. And what I end up with when I do that is I end up with all the terms on this side. And on this side, I end up with 0. And so 0 is going to be equal to 2x cubed plus 3x squared minus 10x minus 15. And the justification for this is the properties of equality. Whenever you do a mathematical operation to both sides of an equation, you're using the properties of equality. In this case, it's the subtractive property of equality. So now I got my third degree polynomial over here on the right-hand side, and I have to, hopefully I can factor this thing. If I can't, then I'm left to try to find a factor and then divide that out to get a quadratic, and it can be kind of messy, but we can actually use grouping in this case. And I just noticed that I'm going to try to group these two terms together and these two terms together and just factor out a common factor from both of them. So the first one, I can factor an x squared out of both of them. I can't factor out a constant like 2 because there's no common factor between 2 and 3 besides 1, of course. But I can factor out an x squared. Oops. So if I factor x squared out of the first term, I'm left with a plain old 2x. And the second term, I'm left with a 3. And on the third and fourth term, they have a common factor, -5. So I'm going to factor out my -5, and I'm left with 2x plus 3. And that still equals 0. So that's useful to me because I see that once I've factored in this way, I have a common factor in both of these expressions. The 2x plus 3 is common. So I factored the groups. That's what I did in this step. And now I can continue factoring. X squared minus 5 times 2x plus 3. So again, I'm just factoring. And that's pretty nice. I also want to imagine if I can factor even more. Sometimes there might be a common factor, like if this was 2x plus 4, I could factor out a 2. Or sometimes this is a difference here, but it's not a difference of squares. If this 5, if instead was a perfect square like 9 or 16 or something, then I could factor this quadratic, but I can't. So I'm going to move straight to the zero product property here. I am multiplying two things, and the answer is 0. So one of those two things has to equal 0. Either x squared minus 5 equals 0, or 2x plus 3 equals 0. And that is, I can do that because of the zero product property. And from here, I'm just going to use the properties of equality to solve both of these little equations. First, I'll add the 5 to both sides. That leaves me with x squared equals 5. And then I can take the square root of both sides, and I get x equals plus or minus 5. I got to include both the positive and negative square root of 5 to have a complete set of solutions. This one right here, right? Subtract the 3 from both sides. I get 2x equals -3. And then I divide both sides by 2. I get x equals -3/2. And those are all of my x values, and I was able to do that because of the properties of equality. Again, if you do some mathematical operation to both sides of an equation, that equation continues to be true. So maybe to finish up, I will just write all my solutions for x using this set notation. And there it is.